So today we're gonna do section 4.3.
Can we do section 6-7?
We
6-7. Sorry.
we did it. I'm sure at some point. Oh no, we haven't done chapter 6 yet, and there's no section 7 in any.
Yes, there has to be. Always. 6-7.
All right. So in 4.3, we're talking about like non-right angled trigonometry. So we've all done like a full course in trigonometry, so these ideas shouldn't be like a new idea. But we'll just kind of go through and do some exampling. I'll write down some formulas and stuff as we go. So like if we asked you to find sine of 120 by drawing triangles. So the idea is we'll start with like an XY axis and draw a 120 degree angle. So we'll draw our initial side. That's on the positive x-axis. And then we'll rotate our terminal side counterclockwise. So it'll be somewhere like over here. So like that section is 90. And that section would be like 30. So that piece is like 120, right? Yeah. So now if I make it, if I make a triangle to the x-axis, that makes a right triangle, correct?
Yeah. That's 60 degrees right there.
That is 60 degrees right there.
90.
So it is a 30, 60, 90 triangle. And I know the ratio of side lengths for a 30, 60, 90 triangle. So sine of 120 is just going to be the same thing as sine of 60. I guess before we do this, though, there was one other thing I should have done when I labeled these side lengths. What's the mistake, the thing I should have done on my side lengths I didn't do?
Also the arrows.
Yeah, on the blue triangle. I made a mistake.
Well, it was because what happened was there's no
Come on, man. What quadrant are we in? Second quadrant. So the x's should be negative in quadrant 2 and the y should be positive.
That's a great catch right there.
So I should label that side that's horizontal negative a. Everyone's all right with that? Now, does it really matter for what I'm doing here? No, because sine is opposite over hypotenuse. So it doesn't really matter. If I did cosine of 135, would it have mattered though? Yes. Because it's the cosine is an x value, correct. Do you guys remember kind of doing this in trigonometry, in your trigonometry classes? Okay, one example good enough? Okay. Next one says, show that for any angle between 0 and 90 degrees, sine of theta is the same as sine of its supplement. So I guess the way I would do this is I would kind of do it geometrically. So here's theta, right? So I'll call that point up there like x comma y. So that side is like x and y, right? If I draw the angle 180 minus theta, it would look like that. Everybody agree? So the points there would be, again, like negative x and y. But I should observe that sine of theta is going to be y over, well, let's just call it r for hypotenuse or something. It's a pretty standard letter for a hypotenuse. And sine of 180 minus theta will also be y over r. I think we did it, right? Yeah, because they got the same thing. So part B says find two different angles theta where the sine of theta equals 0.65. Well, I'll just start by finding one. How would I solve that for theta? Yeah, so you mean sine inverse is the name of that reverse operation, right? So that's one angle. What's a second? Guys. Yeah. So you could do that, right? Everybody's okay there? What's another way you could have done it, though? I would have just set any angle coterminal to the first one we found. How do you find something coterminal? Add 360. So it's an angle that has the same terminal side in the same location. Which all coterminal angles, it's like saying like 1/2 and 2/4 is the same thing, right? Like it's like the unreduced version of an angle, at least in regard to sine, cosine, and tangent. Everybody's okay there? And then it says, show that in a right triangle containing an obtuse interior angle theta and two enclosing sides with lengths A and B, the area is given by the formula 1/2 AB sine theta. So I'll just start by kind of like drawing myself a picture. Everybody good with there? There's an obtuse angle, side lengths AB. So what's the area formula for a triangle? Right? So if I do this, let's make B our base. So the height then for this would be that side, right? Everybody's okay there? What is this angle going to be right here? Not 45. It's 180 minus theta. Right? Because that angle and theta make a linear pair.
Why isn't it not 9 to 45, 45?
Because theta is in 135 degrees.
Oh.
Theta is arbitrary. It just needs to be obtuse. Everybody's okay with that?
But if you get it right in the triangle, you just assume it's 90, 45, 45.
No, you don't assume it unless it says it. Ladies, thank you. Everybody feel okay here?
So you just use like the roll. Just the roll.
So what I can say now is I can find H, right? Because this guy in red is a right triangle, right? So I can say sine of 180 minus theta equals opposite over hypotenuse. Or that H is equal to A times sine of 180 minus theta. And from part A, I know that that is the same thing as just sine theta, right? 180 minus theta is just sine theta. So if I plug that in, then I have 1/2 B and then A sine theta. There we go. You guys feel okay there?
I'm still kind of confused. Why is A sine 180 minus theta? Why is that just A sine theta?
We proved it in part A.
Oh,
Remember? That sine of theta is equal to sine of 180 minus theta. So just use that again. All right. Let's do some solving here. So it says find the value of the missing side length x in the triangle shown in figure 4.27. Correct to 2 decimal places. What's the first thing I should do here?
You can see the third.
Great. What does the third angle got to be?
All triangles at
Correct.
65.
maybe
That's the one. That's the one.
Since we have a 90-degree triangle, what can we use? Well, we don't have 2 sides, so Pythagorean theorem's not going to help us, but we do have a side and an angle. So SOHCAHTOA seems like a good option. So now we should pick an angle to use. Which angle do you want to pick? 25, 65. Can't do 90.
65.
Sure.
Do it.
Relative to the 65, the x is opposite, adjacent, or hypotenuse. Okay, and the 14 is?
Opposite. Opposite.
So which trig function do we need?
Total.
Tangent. So tan 65 equals 14 over x, or x is equal to 14 divided by tan 65. I skipped some algebra there. Is everybody okay with me skipping the algebra?
Oh, absolutely.
Okay. Cool? Okay. So if it's a right triangle, like nothing has changed. Let's take a look at this one, though. What do we notice here?
So you can't find the third angle because you have theta.
Yeah, so this one is maybe not even a right triangle. Is it possible it is? I mean, maybe. Doesn't look like it, but maybe. What do we do if we don't have a right triangle? No, man. There's 2 possibilities.
Oh,
There's the law of sines. LOS just stands for law of sines.
oh, there's loss and law of cosine.
Yeah.
Doesn't the law of cosines have like special rules or?
Well, we should talk about when we use which one, right? So the type of information given to us will tell us what to do. So if I have two angles, like I have an angle side angle situation or an angle angle side situation, that's a law of sines. And also if I have the dreaded SSA situation, what do you remember about SSA from your trigonometry course prior or pre-calculus course? Well, it's definitely a thing, and we definitely have to worry about it. It's the one that has the ambiguous case, where you can end up with a bunch of things that happen, like maybe it's not a possible problem, maybe there could be two possible sets of answers, maybe there can be one possible set of answers. You probably spent like multiple lessons sifting through that because it's not simple. But basically the starting information is going to tell us which one. Okay? So if I look here at the givens, which of the 5 situations do I have? Yeah, look at the givens. Good. This is the side-side angle situation. How do I tell that between side angle side, though? They both have 2 sides and angle. How do I tell the difference? Very good. Yeah. Correct. The 2 sides need to make up the angle and side angle side. So like, if the 60 were there, it'd be side angle side. Okay. Uh-oh, that's the possible ambiguous case situation. But guess what? It's not. So the ambiguous case, if the angle is acute, which is what we have, and the side opposite the acute angle is the bigger of the 2, that's not us, though. That's the ambiguous case situation.
How do you know, like, if it's side or side or side side?
We just said it. That's okay. It's the angle is in between the 2 sides. So if the 60 degree was there, it would be side angle side. Okay. So we're just going to use the regular old law of sines. So we can just say sine of 60 degrees over side 9 is equal to sine of theta degrees over side 10. So the thing you need to remember about the formulas is that the side name and the angle name have to correspond. The side opposite the angle needs to be named the same as the angle, right? And the convention we typically use is upper and lowercase. So we do a little bit of algebra. Do you guys need to see the algebra here to get theta by itself? Cross multiply, divide by 9, and do sine inverse? So we get there about 74.2 degrees.
What do you eat for breakfast?
I didn't have breakfast.
That's the most important meal of the day.
You're talking about right now. No, actually, most countries don't.
Where did you learn that?
In the countries class, probably. All right, let's look at the next one here. What do we got? Yeah, that's correct. This is side angle side. So we'll do the law of cosines. So far, so good. All right, I'm just going to type this into the calculator. I'm actually going to solve for x at the same time. So I'll do square root of 5 squared plus 4 squared minus 2 times 4 times 5 times cosine 30. So 252. You guys okay there? I want to point out to you that there's a check-ish that we can do. So I know that there's a theorem in geometry that says the side lengths and angle measures in a triangle are proportional. So like the shortest side should be opposite the shortest angle. And then like the medium angle should be opposite the medium side and biggest opposite the biggest. So if I take a quick look here, if that number was bigger than 5, I know I would have had it wrong, right? Since I know that 5 would be the biggest side length in that triangle, it would mean 30 is the biggest angle in my triangle, which means that can happen. A triangle, the biggest angle is 30 degrees. I got to get to 180. Now, it's not perfect. Like if my number was 3.52, that's still wrong, but I wouldn't know just from the number that it was wrong. Do we need to do another example of that, or you guys feel okay? You don't have to worry about it. It's not in the curriculum for this course. That's the good news. The answer, though, to the question is that you need an acute angle, and the opposite, or the side opposite the acute angle, is the longer of the two given sides. That's the ambiguous case, where then you have to analyze what you got to see if it's, you do like the law of sines and solve for sine theta and see if the result is bigger than 1, equal to 1, or less than 1. Bigger than 1 is no triangles, equal to 1 is 1 triangle, and less than 1 is 2 triangles. I know, right? It was a lot of fun. All right, let's do the next set here. What kind of situation do we have here? Yeah, that's the easiest one to pick out. Nobody should ever get that one wrong, right? Yeah, it's all the snakes.
Why did you say that? He goes.
Because it's side, side, side.
Oh.
Woo!
Ew. Yeah, let me just like.
All right.
Southern Michigan could see severe thunderstorms.
So, again, the catch here is making sure we're plugging those values in correctly. So, if I name this angle A, that means this side has to be A, and then it doesn't matter after that, right? What's B and what's C? So I would say that 10 squared equals 7 squared plus 11 squared minus 2 times 7 times 11 times cosine of theta. Bye, Nora. Have fun working. Oh, okay. Say hi to your doctor. All right. She has a doctor appointment every B-day, right? Uh-huh. All right. So I just have to algebra this to get the theta by itself, right? So subtract 7 squared and 11 squared from both sides. And then we'll divide by the leading coefficient, negative 2 times 7 times 11. And then we'll do cosine inverse of both sides. So when you're typing that bad mama jam into your calculator, I highly recommend using the fraction command because it takes a lot of parentheses to get that in there the right way. It's always a shame to do the algebra right on your sheet of paper and then get the wrong answer because you can't type in your calculator effectively. So I get 63.0 for that. Your textbook, once again, has the wrong answer for this example, just to let you know. I don't know how they managed to do it because they wrote the answer 64. When it's 63, they just like literally rounded it wrong or something. I don't know. Pretty impressive, I thought. Everybody still doing okay? Remember doing this? Stuffs from before. It's not bad. You're mostly just using the formula. No, that's spectacular. Okay. The triangle shown. We're solving for the side length x, the angle measure theta, and the area of the triangle. Oh boy. All right, so if I take a look at this, we'll make that a little bigger maybe. So we're solving for x first. What situation do we have here? Side angle side. So we know x squared is equal to the square root of, I guess that we're writing x squared. I don't need that. So when I grind this through on my calculator, I get 16.2. So how am I going to solve for this theta now? We can do law of sines or law of cosines. You have enough information now to do either one. Which one is the easier of the two to use? I think so too. So we'll do sine 27 over the 16.2 equals sine theta over 30. Everybody cool with that? What's the downside of doing it this way? You have your previous answer in the problem, which kind of stinks if you did it wrong, right? That's what showing your work for, though, is we're just praying that that helps us out. Everybody feel good there? Note that you couldn't have done part B without part A first. You needed that side length. Part C then says it wants the area. Well, that's easy. Right, 1/2 AB sine C. So that's just this right here. Anytime you have a side angle side situation, we are tailor-made for an area formula. Oh my gosh, guys. Well, yes. look at our picture and look at our answers. That ain't right, is it?
It's over the limit.
What is that telling me then? Nope. We ran into the ambiguous case.
Oh, I forgot about that.
Well, we did a side angle side where the longer side was opposite the or the shorter side was opposite. We ran into an ambiguous case. We don't want the acute answer here. We want the obtuse one. Yeah, we did have these in here. Oh my gosh, textbook. You know what the textbook wrote down here? It wrote down 180 minus 57.2 is 123.8.
Yikes.
Yikes.
This textbook sucks.
Yeah, the editing is just, this is like the rough, like a beyond rough draft bad. Like whoever they hired to edit it didn't edit any of the math, they just edited the grammar.
Good question. But we found the area, like part A on the side of the what formula did you use to do that again?
So we used that area formula that we proved before in part C.
Why is it X?
There's no x squared I see anywhere.
Like X squared up. Oh, I meant like part A.
Oh, that was just the law of cosines.
Oh,
Because we're not finding an area, we're finding a side length. Is that cool?
yeah.
Okay. We got some of these navigation problems. Now, the kids that took trigonometry and pre-calc with me last year, I know how we did these problems. Those of you that took the AP pre-calc course, did you guys remember doing these navigation problems?
I don't remember anything.
Okay, do you remember how you did them? Did you draw like a triangle or did you use vectors? I want to use
Vectors feel right.
I want to use vectors to do this as well because I think it's massively easier than the geometry involved with getting a decent triangle. You probably did both. Is probably the right answer. I'm going to only show you the vector way because I think it's the easier way. So if we read this, it says an aeroplane, well, I guess we're in England, flies 280 kilometers at a bearing of 9 degrees from Calgary, Alberta in Canada, as opposed to Calgary, Alberta in Uzbekistan or something, to the provincial capital, Edmonton. From Edmonton, the plane flies 1,320 kilometers on a bearing of 72 degrees to Churchill, Manitoba, located on the shores of Hudson Bay. I love all the extra flavor. How far is it from Churchill from Calgary? So when I read this, to me this sounds like a 2-leg journey, right? I have that leg and then that leg, right? So when I read that, I just see 2 vectors. I'm going to call them U and V. So I'm going to draw a picture for U. So if I'm doing bearing, I know my bearing starts at the north line, and then we go clockwise 9 degrees, Everybody okay there? And the length of that vector is the 280 kilometers. What I want to do to start is to translate that from a bearing to a standard position angle. What is the standard position angle that I've drawn in there in green gotta be? How much less than 90 degrees? 9 less.
Wait, this is not considered drawing a triangle.
When I say drawing a triangle, like it, I'll show you afterwards what it would look like, but it stinks. So I'm going to resolve this now into a vector. So I'm going to do the magnitude of the vector times cosine of its standard position angle, 280 degree, or magnitude times sine of its standard position angle. Done. Then I'll do my other vector. That's vector v. So again, I'll start with my bearing, and it said that bearing was 72 degrees. And its magnitude was 1320. Yeah. And again, I want to resolve that into a standard position angle. What is standard position angle? Is that got to be? You mean 72 less than 90. So 18 degrees. So if I want to do part A then, I'm going to say R is the vector from Churchill to Calgary. So that's just going to be the result U plus V. Okay. So like if we're drawing this picture, like this is Calgary, we do like vector U to Edmonton, and then we do like vector V to Churchill. So that's like our vector R. Yeah? So then to find the magnitude of R, which is going to correspond to its length, I'm just going to take the square root of the component squared. So let's do that. So for my first component, I'm going to get the component from U plus the x component from V and then we'll do the same thing with the y components. You're welcome. How'd your reading go?
It was a bio test. It's okay.
Well, I meant without your glasses.
It was fine.
Okay. So the components are 299.2 and 684.5. So there's my magnitude calculation. You guys remember doing magnitudes with vectors before? Yeah, I think this is so much neater and cleaner than trying to draw the triangle and do a law of cosines thing, which is the way the textbook wants to do it, but like, I get why they wanted to do it that way because they don't have to do any vector stuff, but we've already done all the vector stuff. Let's use them. So I get 468 or 1468.5. Does that feel okay? So the way the textbook would have you do this is to like carefully draw all these triangles kind of butting up to one another and then like turning it into a non-right triangle and using like the law of cosines or something here, which is fine if you want to do it that way. To me, that feels unnecessary, like more difficult than it's worth. Part B then says, the airplane flies an average speed of 720 kilometers per hour. How long does it take on a direct flight? Well, I just take my total distance that I have to travel by my rate of travel. So that's easy enough. And I get about 2 hours and 0.04 minutes. It's a quick flight. Probably doesn't account for all the taxing and all that gobbledygook. Okay, you guys feel okay here? The final section in chapter 4 is talking about surface areas and volumes. Yeah, SAT stuff, apparently. So I've just dropped in some common surface area and volume formulas. This kind of stuff would be given to you and have to memorize this. But you might have to have enough common sense that you can look at the formula and adapt it for your specific situation. All right, so let's do a couple of examples. We won't finish all this stuff, so we'll just finish this on the quiz day or something next time. Example 423 says an ice cream cone has the shape of a right circular cone with a radius of 3 centimeters and a height of 8 centimeters. Calculate the volume of the ice cream cone. Well, if I go back upstairs, I see that the volume is 1/3 pi r squared h. So I just plug them into the formula and enter it in my calculator, and I'm done. If I do the surface area calculation, it says that's pi r squared plus pi rs, where the s here is like the slant height of our cone. But I need to think real hard here about the surface area situation. The surface areas, the context of the problem are going to matter to us. If I have an ice cream cone, is there a surface, is that part a surface on your ice cream cone? No, man, that's where the ice cream goes, right? It's just the outsides, right? You get what I'm saying? So this guy goes bye-bye. Oh, there it is.
Good afternoon, Notre Dame. Let's pause and end this day together in prayer. In the name of the Father, the Son, and the Holy Spirit. Amen. Dear Lord, thank you for seeing us through today and the rest of this week. Thank you for the love and grace you've shown us, for the many ways you've blessed our lives. Please help us to love others with your love and to be a source of kindness, comfort, and encouragement to those around us. We ask these things in Jesus' name. Amen. Teachers, you may dismiss as you are ready. Have a great afternoon, Notre Dame, and God bless.
The quiz info is on My Notre Dame. We'll finish talking about this next time after the quiz. Correct.
Thank you. The test tomorrow is
Correct.
test tomorrow is just chapter 9, right?